Hello students, let us solve a question from GATE 2018 and question number 42, and this is basically from nuclear physics. Subtopic is radioactivity. So in that question it is given that you have a thorium nucleus having atomic number 90, mass number 230. It is decaying alpha particle. So as you know that alpha particle is nothing but doubly ionized helium. Doubly ionized means 2 plus. It contains 2 protons and 2 neutrons without any electrons. So this nuclei is emitting alpha particle. You have a daughter nucleus that will be radium, atomic number 88, mass number 226. Okay. So this decay process is mentioned, and also it is mentioned that beyond the separation between radium nucleus and alpha particle, there's only or purely Coulombic potential is exist beyond their separation. So basically you have to calculate the height of or Coulombic barrier height that you have to calculate. You have to calculate Coulombic barrier height. And also it is given that E square by 4 pi epsilon naught, that is 1.44 mega electron volt femtometer. And R naught is given as 1.3 femtometer. So basically you have to calculate barrier height, and it's clearly mentioned that beyond the separation means beyond the separation between alpha particle and daughter nucleus, only or purely Coulombic potential is exist. Now if you plot that, to solve that question or to calculate that barrier height, Coulombic barrier height, first you have to draw that potential that is facing by alpha particle while it is crossing out from nucleus. So as you know that the nature of nuclear potential with separation R, that nuclear potential is look like V of R versus R, it will be look like this kind of. So this is a 0, this is R. So we'll discuss each and every term. And beyond R, beyond the separation, only Coulombic potential is exist. Okay, so this is the kind of nuclear potential. This is the this R is basically denoting the separation between center of daughter nucleus to that of center of alpha particle, and this is the point R. R is the point when that surface of daughter nucleus just touching the surface of alpha particle. So if you define that R is the situation where surface of daughter nucleus, let us take that daughter is this radium, and you have an alpha particle. The surface is just touching. So this is your R. So beyond this R, only Coulombic potential exists, and you have to calculate, or according to that question, you have to calculate this barrier height. This height you have to calculate. So let us take that barrier height is B. Okay, as you know that barrier height is quite large as compared to the kinetic energy of emitted alpha particle. The kinetic energy of emitted alpha particle that you can denote like K alpha, that is only around 4 to 9 mega electron volt. So classically that alpha particle cannot tunnel through this barrier, but quantum mechanically, if you have a energy of the particle less than the barrier height, still there is certain probability that this particle, quantum particle, can tunnel through this barrier with certain probability that you know from quantum mechanics because of wave nature of particles. So wave can tunnel through barrier. But here you have to keep in mind that barrier height is no longer constant. It's varying with separation between separation between daughter nucleus and alpha particle. So this nature, you know, this nature is given beyond the separation, that is given that potential is exactly or purely Coulombic potential. So that you can write, if the charge of parent nucleus is Z, it will be Z minus 2. So beyond that separation, that Coulombic potential is written like 1 by 4 pi epsilon naught. That is the form of Coulombic potential energy Q1 Q2 by R. Right? And Q1 is the charge of daughter nuclei and Q2 is the charge of alpha particle if you substitute it. So you'll have 1 by 4 pi epsilon naught. Q1 is the charge of daughter nuclei. The charge will be how much? That will be 88 times electronic charge because it contains 88 electrons. So 88 E you can write, and then you have a charge of alpha particle that will be 2 times electronic charge divided by. So you have to calculate barrier height. That will be separation at R. This is barrier height you have to calculate. So you have to substitute that R is here R. Now you can find that R because you know that R is nothing but radius of radium atom, and you have a radius of alpha particle. And you know there is a famous equation that radius of nucleus is nothing but R naught to the power 1 by 3, where A is the mass number. Now I can write this. So I can write this RA, that will be nothing but R naught ARA e power 1 by 3 plus R naught A alpha e power 1 by 3. I'll substitute that. So you'll have R naught times ARA e power 1 by 3 plus A alpha e power 1 by 3. Okay. So if you substitute it, you will have R naught that is given 1.3, and then RA is how much? That will be the radius of this, ARA. This is the mass number of daughter, that will be 226 to the power 1 by 3 plus mass number of alpha particle, that will be 4 to the power 1 by 3. So if you calculate, you will get 7.67 femtometer. So this is the R value when the surface of daughter nucleus is touching the surface of alpha particle just before their separation. Now they will separate each other. At this situation, you will have barrier height, that will be B. So that can be written as VCR, or VCR means Coulombic barrier potential R. That will be simply B. So here we will substitute that value. Let us substitute that. So you have a E into E, that will be E square. So I can write E square by 4 pi epsilon naught. And then you have 2 into 88, right? And then you have R, that is, we have obtained 7.67 femtometer. Now if you substitute that E square by 4 pi epsilon naught, that is given as 1.44 mega electron volt femtometer. And you have 2 into 88 divided by 7.67 femtometer. So this femtometer will be cancelled. This femtometer will be cancelled. And if you calculate, you'll get 25.99 mega electron volt. So this is the Coulombic barrier height when the surface of daughter nucleus is just touching the surface of alpha particle. Okay. So this barrier height is quite large as compared to the kinetic energy of alpha particles. Still, it can tunnel because of quantum nature. Okay. Thank you.